Today we're talking about writing equations of transformations of the exponential and log functions. These are very similar to everything we've done so far. We're going to look at the equation. We want to let the graph G be a reflection in the x-axis, followed by a translations to unit left of the graph of f of x equals 2 to the x plus 9. So we are going to start with the reflection in the x-axis. So that, remember, that is negative f of x. F of x is the whole equation, so everything has to change. So negative 2 to the x plus 9, which makes negative 2 to the x minus 9. Now the negative is not being raised to that x power, so we're not going to put parentheses around anything there. Then the next thing is followed by a translations 2 units left of the graph, so that's f of x plus 2 to go 2 units left, and that gets plugged in for the x in the equation, the one we just finished, so negative 2 to the x plus 2 minus 9. And that's our function g of x equals negative 2 to the x plus 2 minus 9. Our next equation is on a log, or our next transformation is on a log. Let the graph of G be a translation 1 unit down, so that's going to go first, followed by a vertical, let's color code these, a vertical stretch by a factor of 5 of the graph f of x equals log base 1/8 of x minus 6 plus 2. So 1 unit down, that's f of x, hold on, need a pen, f of x minus 1, that's 1 unit down, which is log base 1/8 of x minus 6 plus 2 minus 1. So this is going to become the log base 1/8 of x plus 6 plus 1. Now we're going to do a vertical stretch by a factor of 5, which is 5 times f of x. So the whole equation gets multiplied by 5. This is what we're missing if we're missing these types of questions, is we're forgetting to distribute to the k factor. This is our k factor. Our vertical shrink and stretch is affected by, or not, sorry, our vertical translation is affected by our vertical shrink and stretch. So we want to make sure we distribute properly. So we get, and I'll write in red, 5 log base 1/8 of x plus 6 plus 5, because I have to distribute to the 1. And that's my final answer there. Let's look at 2 more examples. We're not going to do a ton of them today because this is not something that's brand new, but it always helps to just have your brain refreshed. So we're going to do first the graph be a horizontal shrink by a factor of 1/2, followed by a translations 5 units up. So we'll start with the horizontal shrink. That's f of 1. Ooh, is it 1/2 x or is it 2x? Remember that when we do our horizontal shrink and stretches, they switch, right? So it's going to be 2x. So f of 2x equals e, and I'm plugging 2x in for my x, so 2x minus 3. Then it says followed by a translation 5 units up, so that's f of x, we'll do that in blue, f of x plus 5, and we get e to the 2x minus 3 plus 5, and that's our final answer. And this one, let the graph be a translation 2 units down, followed by a reflection in the y-axis of the graph f of x equals log base 3 of x minus 6 plus 4. So let's go what's first, translation 2 units down, followed by a reflection in the y-axis. So 2 units down is our f of x minus 2, which is the log base 3 of x minus 6 plus 4, and then minus 2, which is log base 6 of x minus 6, log base 3, plus 2. And then a reflection in the y-axis is f of negative x. So log base 3 of negative x minus 6 plus 2. And when we have that negative x in there, we could write it also as x plus 6, because when we're at x minus 6, that translates it to the right 6. And when we're reflected in the x-axis, it translates it left 6. So you could also write this log base 3 of x plus 6 plus 2, because it flips it over the y-axis. Okay, I'm going to do one more. Okay, and our last example is let G be a horizontal translation right 4 followed by a reflection on the x-axis. So we have a horizontal translation right 4, and then we have a reflection on the x-axis. So f of x is log base 5 of 1/2 x minus 9. That minus 9 is on the outside. And we want to do a horizontal translation right 4. That's f of x minus 4. Oops. And I'm going to plug that in to my x. And when I do that, it has to multiply log 5 of 1/2 times x minus 4. That 1/2 multiplies to the translation, and then minus 9. So then we get log base 5 of 1/2 x minus 2 minus 9. Then, so make sure that distributes. Then the reflection on the x-axis is negative f of x. So that's negative times log 5 of 1/2 x minus 2 minus 9. That negative is going to distribute to the 9 and stay in front of the log. So your final answer is negative log base 5 of 1/2 x minus 2 plus 9. Okay, so don't forget those distributing, especially when there's a vertical shrink and stretch, horizontal translations, when you are when you have a coefficient on the x, and the reflections on the x-axis. Those are especially important.